Hi students. So in this video we started the class 9 physics third chapter, that is gravitation. We already finished the two chapters of physics class 9, that is one is motion and one is force and laws of motion. Now take the gravitation chapter here. So see, whenever we heard about the word gravitation, we recall that story of Newton and the apple. Once it is said that once a Newton sitting under a tree, and a apple fall on him, and that apple when fall on him, the phenomena is observed by Newton. He not eat the apple at all, he observed that phenomena. He observed that why the apple when cut from the tree come towards earth, why not it go into the space, right? There are two options is there are so many directions are there. When the apple is cut from the tree, maybe it go left side, maybe right side, maybe north, east, any side, but maybe up in the space. Why the apple attracted toward there, that is big question is there, right? So that is a phenomenon observed by the Newton. When the apple or anything is there, put a ball, throw a ball in the space, what happened? After some time it reach a height, yes, and automatically it is fall towards the ground, that is towards the earth. So that phenomenon is observed by the Newton, that the apple is falling towards the earth. So Newton make a question that why the apple is attracted by the earth, why fall towards the earth, why fall towards the earth, why not go into the space, not going right, left, anything in directions, why it is always fall towards earth. So after Newton conclude that from this observation, the Newton conclude that the apple is fall on him or towards the earth is because of the force, and that is force is called as an gravitational force. So Newton say that the every object on the earth that is attracted by the earth, that is because of the force, that is a gravitation force. So because of that observations, finally Newton come with a very important law, and that is called as a universal law of gravitation proposed by the Newton, that is a universal law of gravitation. And this universal law of gravitation is very important, and it not only holds good for the earth, it is also holds good for the space or space bodies. For example, we say that the universal law of gravitation is applicable for earth, that is terrestrial object, and also for celestial object here. So let us start the law, that is what a universal law of gravitation. Universal law of gravitation. Okay students, that is very important statement. So most of the time in the examination for 1 or 2 marks state universal law of gravitation. So let us start to state the universal law of gravitation here. So take first statement and then come to the further discussion here, right? So let us start the statement here. Every object in the universe attracts every other objects with a force which is directly proportional to the product of masses and inversely proportional to the square of the distance between them. The force is acting along the line joining the centers of two objects. So students, this is very important point you have to remember here. So see, this is statement the Newton given, that is what, the universal law of gravitation. Why universal law? Because it is applicable for both terrestrial objects and also for celestial objects. Okay, so it is called universal law. So this statement also about universe, right? In the universe we take anything is there, we take the attraction of the other object towards the earth, okay, or attraction of the moon towards the earth, or the attraction force between the planets and between the sun, and all things, all the objects that all having some attraction between each other. Okay, the sun attract all planets, all planets attract sun, and the earth attract moon, moon attract earth. Okay, earth attract apple, apple attract earth. All these things is there. That is called in the all universe. In the universe we observe that the every object, okay, every object in the universe, maybe it is big object, maybe it is small object, right? Also remember that this universal law of gravitation is applicable for small objects and big objects both, right? Maybe object small, maybe object big, that is called universal. Or maybe object terrestrial or maybe object celestial, that is universal. Okay, any object attract the other object with a force F, right? And which force F is directly proportional to the product of masses and inversely proportional to the square of distance between them, and the force direction is acting along the line joining of the two objects center. Let us see what is the statement actually. So as per the statement, I take two bodies. Okay, every object is there, so I take two body. That is one body I take here of mass, I take capital M, right? And the other body I take here, right? That mass is small m, right? Two body of some mass is capital M and small m, and these two objects are separated by a distance r. Okay, from the center. Okay, center of the earth, center of the object, right? This distance from measure from the center, right? This distance separation is taken from the center, that is mass capital M, it is small m, and this is the distance between the, okay, I can take this AB. Okay, AB is the distance between two objects, and that AB length I taken as taken D. Okay, taken as D. In the sum book you observe that the distance is D. In the sum books maybe they take answer small r. Okay, small r also stand for this distance. You may take RD or you may take R. Okay, but here as per NCERT I take D here, right? So see here, two objects of mass capital M and small m separated by distance, that is D, right? Now what happened as per the statement, every object attract the other objects with a force F. So means that this, okay, so means that, see or observe that this A attract this by F force, and at the same time this object attracted this by same force, that is at force of attraction, and this force of attraction direction is there along the line joinings. Okay, line joining, see again, the what is the direction of force here, right? So the direction of force is acting along the line joining the center of the object. Okay, from the center of the object we take the directions, right? So this is students as per diagram. So let us take here mathematically. So what say that the force F, okay, see here the force which is directly proportional to the product of masses. So I can take the force F is directly proportional to the product of masses, that is equation 1. And second say that, and the same force is inversely proportional to the square of distance. Okay, square, what is distance here? D is there, so I can take D square, that is equation 2. So now combine 1 and 2, right? Combine 1 and 2. So what we get? We get F is directly proportional to M, product of masses, and inversely proportional square of distance between them, right? So now I can remove this proportionality sign. So I get here, see, F is equal to capital G into mm by D square. Okay, so this is what students, the mathematical statement of universal law of gravitation. See here, F is directly proportional product of masses, and the F is inversely proportional square of distance between them. Where what is G here? So here see, G is a proportionality constant called as universal gravitation constant. right? So that point is very important. So G stand for proportionality constant, that is called as universal gravitational constant. Why universal? Because the value of G, that is capital G, the value of capital is same. If you calculate the force F in your room, so we can take G value same. If you calculate the value of F in the school, okay, in the school laboratory, you take the value of G same. If you calculate the force F in the space, that is the value of G is fixed. If you calculated this G on the moon, the value of G is fixed. If you calculated F in the Jupiter or Mars, anywhere, the value of G is fixed. That is called universal constant. Okay, the value of G fixed for everywhere, so that is called as a universal constant. So that is what capital G stand for universal gravitational constant. So the formula is F standard force of attraction and G stand for universal gravitation constant, and M is the mass of this one object, small m is the mass of the other object, and D is the square of distance between them. So this is what, students, this is called as the mathematical form of universal of gravitation, mathematical form. So please write down this one. Mathematical form of universal of gravitation is means, that is the answer, F is equal to G mm by D square. In the examination they ask state Newton universal of gravitation, so you can write this statement and final this formula, or also there is the explain, right, state and prove universal of gravitation. So you write all these things, right, you have to mention this one, students. Okay, so please write down all these things here. Okay, now students, after statement take the formula, right? So in the formula I'll write all the quantities, right, the meaning of all the quantities here, right? So we know that the formula, that is what, the F is equal to G into mm by D square, right? So this is a very important formula. This is called a universal law of gravitation, where I write here G stand for force, okay, F stand for force, okay, and then G stand for universal of gravitation, universal gravitational constant, universal gravitational constant, okay, and here M and M stand for product of masses, right, product of masses, and here D stand for distance between between objects. Okay, so these things you have to be remember, students, right, very important point to be remember. Now some discussion about G here. So here see G, so G has value which is we take as 6.673 into 10 to the power, okay, minus 11, that is Newton meter square per kg square. So that is what the value for G here. What is the value of G? So I say that the value of G is constant, and that constant value is this one, okay, this 6.673 you write, or maybe 6.67, that also both are same, okay. In some books they given 6.673, in some book they given 6.67 only, okay. So both are same, okay, you may write this, but is a constant. You may be calculated the force in anywhere, in your bedroom or in your classroom or in Jupiter, on Earth or Moon, anywhere you take the value of G is this only fixed, that is called universal gravitational constant, that is 6.673 into 10 to the power minus 11, students. Okay, now this is about the G value. Now see here, students, if I make some changes here in the formula, cross multiplication, right, that, so see here I can make some verification here. I can want the value of G here. So what I do, I put G like that. So what happens here? D this side. So what happened? F D square, right? F D square and mm this side, divide m. So this is what the value of G. How do we calculate the value of G? By putting these values, putting the F, putting the D, and putting the value of mm. You get the value of G here, right? And this calculated by, okay, this value of G, that is 6.673 is, okay, calculated by the scientist, okay, calculated by the scientist, and I am the scientist like Henry, okay, that is a Henry. So Cavendish, okay, by using, so the year is that is not important, but write 1731 and 18, 10. So by using a sensitive balance, okay, sensitive balance, right? And see here, we can easily find now the SI unit of G is, okay. So what is the SI unit of G here, students? So simple, see here, the SI unit of G is, so G is equal to simply, so what is F here? Force, that is Newton, okay. D in meter, so D square meter square, D square meter square. For finding the D distance we take meter, so D square means meter square, okay, divide by mm, kg into kg, kg square. So this is what, students, the SI unit of G also, and I have mentioned here, see, Newton meter square, kg per kg square. So how it is come? Like that, okay. F Newton, distance m meter square, and then mm kg square. So that is Newton meter square and kg square, right? So per kg square. So this is what, students, about the SI unit of G is there. So that is very important point you have to be remember, the universal law of gravitation and their full derivation, that is F is equal to G into mm by d square, and also take the G is equal to Fd square by mm is simply by cross multiplication. And we also come to remember the form that is constant. G value is 6.673 10 to the power minus 11 Newton meter square per kg square, and this value of G is same for every object, okay. And this universal law of gravitation is applicable for small objects and for big objects and for object in terrestrial, or the object is present in the celestial, okay, in the space. For all these, for all the places, this universal law of gravitation is holds good, and the G stand for universal law of gravitation, and this constant value is applicable for all the things. For big object same value, the small object same value, for earth same value, for space same value. So this is called universal gravitational constant, and it is be calculated by the scientist Henry Cavendish in the 1731 to 1810, and by using a instrument that is called as a balance sensitive instrument, sensitive balance instrument he used to find this value, that is 6.673 into 10 to the power minus 11, okay, students. So this is all about the gravitation, okay, universal law of gravitation. Now students, come to write one note here, very important, right? See, that is the law is universally in the universe, okay. We said universe, okay, universal in the sense that, okay, why we say it is universal, that I already explained, because of it is applicable for bigger, smaller and all the objects, okay. Universal in sense that it is applicable to all bodies, right? Whether the bodies are big or small, whether they are celestial or terrestrial, okay, terrestrial or celestial. So that is what, in that sense we say that it is universal law of gravitation, okay. It is not for only earth, it is for all the universe objects. So in the sense that it is applicable for the small bodies, okay, small bodies or big bodies, or whether the object is celestial or whether the object is terrestrial, okay, present in the space or present in the earth, or maybe small or maybe big, for all the object it is universally holds good, that is F is equal to G mm by d square. So please write down this one, that is what the importance of the application of why, in what sense we say that it is universal. So that is the sense, because of that we say that universal law of gravitation. Please write down this one, we continue our discussion on that, right? So about the importance of the gravitation, and also for inverse law, okay, this follow inverse law, what is that inverse law and what is the importance of gravitation, we take first write down this one, okay. Now take the next point, is inverse law here. So see what say, it is saying that F is inversely proportional to the square of D. So we already write in the let's just that is f is inversely proportional to d square, right, in the derivation. So see, correct one. What does it mean? It is actually the inverse law here. What does it mean? See, for example, that if d get bigger by factor 6, take 6 factor 6, 12 or 18, anything, I can 6 here. So what happens here? If I take to increase the distance, okay, 6 times I increase the distance, what happens here? 36, okay, that is correct. 6 square, so we get what? So f is, that is 1 by 36 times smaller. So it is get reverse. I increase the distance, what happened? At the same time the force is decreases, that is inversely proportional. Increase the distance, the force is decreases. I increase the distance 6 times, what happened? The force decrease, okay, how much? 36 times. That is the inverse square law is there. So that is the inverse square law, students. Okay, inverse square law, okay, not inverse law, inverse square law, right? So that is inverse square law. So whenever, for example, I can increase the distance by the 5 factor, what happens, student, by factor 5. So what happened of force? Right, the force is now 1 by 5 square, that is 1 by 25 times smaller. If I increase the distance by 10 factor, what is the force? You are right, that is 100, 1 by 100, simple. So f is equal to 1 by 10 square, so that is f is equal to 1 by 100. So that is what inverse square law, students. Okay, if I increase the distance between the objects, so what happened? The force get decrease. Okay, whenever the distance between object increases, the force between the object is get decreases. So that is the universal square law. Say that how much increase, how much decrease, that is square times increases and square times decreases here. So that is, students, very important to be remember. It is about inverse law. So please write down this one. Now students, come to the last point of today's class, that is the importance of universal law of gravitation, and that is important for examination also, right? For 2 to 3 marks, write the importance of universal law of gravitation or gravitation force, right? So write down, please. Take a title here. Importance of the universal law of gravitation. Okay, universal law of gravitation, that is what the gravitation force act here. Okay, we observe that the force attract every object. Okay, the moon attracted by the sun, the moon is attracted by the earth. So what important is, so that is the first important. See, students, the value of g, that is one importance of gravitation is, first one, the force binds that, the force that, okay, that binds us to the earth. It is the first one, right? To the earth. Okay, through any objects, all objects are attracted by the earth, so we also stand on the earth, okay, walk on the earth. It is because of the gravitational force, that is the earth hold us because of the gravitational force. If there is no gravitational force, what happened? You must be imagine that one. Okay, right. Now next one, that is the motion of the moon around the earth. That is the answer, right? The motion, we know that the moon is revolve around the earth. It is because of the gravitational force here, right, students? If there is no gravitational force, what happened? The moon can be moved in the straight line, but we observe the moon is having a circular rotation, okay, uniform circular motion around the earth. It is because of the gravitational force. If there is no gravitational force, the moon not follow the circular path, it can follow the straight line path. So because of gravitational force, the moon can be have uniform circular motion, students. Okay, because of the gravitational universal law of gravitation. Next, the planets, the motion, okay, the motion of the planets around the sun, okay, around the sun, it is because of the gravitation. Okay, we observe that the motion of the earth, the motion of the Mars, Jupiter, Neptune, anything, that is what? Because of the gravitation, right? Next, and we say that the tides due to due to the moon and the sun. Okay, that is as tide waves. We observe that in the ocean the waves are formed. Okay, water waves are formed. It is because of the gravitational force, that is the gravitational force between sun and moon, that create an the tides in the ocean. So student, this is all about the importance of the, so please note down all these 4 important. They are for 2 marks. In the examination they ask for 2 marks. Write the importance of universal law of gravitation. That is very important. It binds us to the earth, motion of the moon around the earth, the motion of the planet around the sun, and also the tide formation due to the moon and the sun. It is all because of the universal gravitation, that is universal law of gravitation, students. Okay, so that is what important of gravitation. So today video we discuss about the universal law of gravitation here, and the statement and the derivation and the formula, that F is equal to G mm at d square, and also we take the value of G here. G is equal to FD square by mm, and the SI unit of G is what? Newton meter square per kg square, and the value of G is 6.673 into 10 to the power minus 11 Newton meter square and per kg square. And also we take about the this universal law of gravitation is called in the sense of universal because of it is applicable for both the small objects and the big objects, and also applicable for the terrestrial object and the celestial objects. And also it follow the universal square law. How it is, if I increase the distance by 6 factor, what happened? The force can be decreased by the 1 by 36 factors. Okay, square is there, so because of 6 square is 36. So if you take 5 means 25, 4 means 16, that is square is there. So that much water, if the distance increases, the force is what? Decreases. That is the universal square law it follow. And also we say about the importance of the gravitation here. So that is all things we study today. So in the next video we take about the free fall body in the next class. So but this is for today students. Okay, so here closed class is closed. Meet in the next video with the next important concept, that is the free fall body and some very important problems. Okay, so thank you so much for watching this video.